Hello. Um, Today I'm going to show you how you can use a tool called Seer to build interfaces, specifically command line interfaces to your smart contracts. Um, I'm actually going to show you how it works by building an interface to one of my smart contracts and then interacting with a deployed instance of that contract. The contract itself isn't important. Seer will work on your smart contracts the same way that it does on my smart contracts. I just want to show you the flow of how you can use Seer to do this. Seer was inspired by Abigen. So if you write Go code, in the Ethereum ecosystem, you're probably familiar with Abigen. It's really a great tool. Abigen generates Go bindings to Ethereum EVM smart contract, methods, events, and stuff like this. But the thing that's always been lacking for me in ABI Gen is, I want a little bit more than Go bindings usually. The convenience factor would go up much higher if, in addition to the Go bindings, I could also get a command line interface to the smart contracts. That helps a lot with scripting and operations and stuff like this. And so that's what we built with Seer. So in order to use Seer, you need to have the ABI of your smart contract and the bytecode, the compiled bytecode for the smart contract. In my case, my smart contract is built with Foundry. So I'm just going to use, I'm going to extract the ABI and the bytecode from my build artifacts, okay? So, okay, so let's put the ABI in abi.json. And let's get the bytecode and put it in the file called BC. Right, so I have abi.json, and this contains my smart contract ABI, and then I have this file called BC, which contains the bytecode. So we can look at, there's my ABI, and there's my bytecode. All right, cool. So now that that's ready, let's actually run Seer, and let's see how long it takes. Okay, so Seer generate. It takes a bunch of arguments, but I'll sort of walk you through them as we do this. So first I need to specify the path to the ABI. Then I need to specify the path to the bytecode. If I don't pass the CLI flag, it just outputs the same thing that Abigen would output. But if I want to have a command line interface, then I need to just specify the CLI flag. Include main, this makes the whole thing self-contained. So by default, you could use this as part of a larger CLI that sort of works with multiple contracts. In this case, I just want to make a CLI for my smart contract self-contained. So I put include main. I'm going to tell it that I want to output this stuff to, let's say, full. Let's give it package main. So this is like the name of the Go package that should be generated, and then a name for the Go structure that should be generated. So this can be the same as the name of the smart contract. Okay. All right. Let's run this. It took about 124 milliseconds, right? And now I have a file in my directory called fullcount.co. Let's have a look at that file. So if you've used Abigen, this will look pretty familiar to you for good reason, because the first part of the file is exactly what's generated by Abigen, right? So both the Go Ethereum package Geth, it has this function, it has this package called bind, which creates bindings for smart contracts, and both Abigen and Seer, they use that bind functionality in order to generate this code. But what Seer does is it adds, well, this is the entry point for the command line. It adds this function called main, which invokes this create command function, which actually defines the command line interface. And all of this is code that's generated by Seer to present a command line interface for the smart contract. right? It's very hard to look at code that quickly, so I won't subject you to it any further. Let's actually build this file and use the command line interface, okay? So if we want to build this file, let's create a Go module, okay? Get our dependencies. So all standard like Ethereum dependencies, right? And then build. Now, if we look in our directory, you'll see there's this executable file called full count, and this is a pretty big command. There's a lot of methods, right? Basically, it's a pretty hefty contract. So let's look at it like in a more leisurely fashion. The command line sort of classifies the subcommands that you can call. There's the deploy command. Because we provided the bytecode, we can actually deploy the contract whenever we want. You can call any view method on your contract, or you can submit transactions on your contract. In this case, just to see how it works, let's call a view method. Let's count the number of at-bats and the number of sessions on my contract, right? This is completely custom behavior to my contract. So let's try it out, okay? So if you want to use this, let's see, full count, num at-bats. If I want to call this command, there's a bunch of optional arguments, like, at what block number I want to execute, like call the view method. Do I want to simulate the call from like a particular Ethereum account, and so on. The only ones that are required here are you need to specify the contract address, and you need to specify a JSON RPC URL for the node that you want to execute the call on. So let's do that. So I have in my environment, I have environment variables. So let's do our contract is deployed on Arbitrum Sepolia testnet. Full count address. Okay, I have the address saved in an environment variable as well. I can call this method, and the output format is, these view methods, they could give you multiple return values, right, in a tuple. And so the way that Seer displays that information is it gives you the index of the return value, and it tells you the value itself. So in this case, there's only one return value, so the index is 0, and the number of at-bats on this contract is 1. It was just recently deployed. Okay, and I can do the same thing for num sessions. 1. It has 1 session as well. Okay, you don't have to worry about the specifics of like the data structure and so on over here. And we can even get more information. We could submit transactions if we wanted to do, or call other view methods. But I think this demonstrates sort of the convenience of having a command line interface to the contract and generating one with Seer. If you would like to use Seer and you have trouble getting started or anything like this, you can reach out to me or to anyone from the Moonstream team in Discord. I'll add a Discord link in the description to this video, and you can check out the code. So all this tooling is open source, as almost everything that we build. And so if you would like to have a look at it, you can go to the Seer GitHub. It's github.com/moonstream-to/Seer. Thank you.